run select star from articles where body like person checkout person on 100 million rows, and your database will happily scan every single one of them. That query can take 30 seconds, sometimes minutes. Elasticsearch answers the same question in under 10 milliseconds. Same data, same box, roughly 100,000 times faster. That's not caching, and it's not just more servers, it's completely different data structure underneath. So let's actually open it up, how search really works, and why your database was never built to do this. Here's the thing about a normal database index. A B tree is fantastic when you know the start of a value. Where email equals a@b.com is instant, name like John percent is still fast, but like percent, checkout percent, that leading wildcard throws the index away. Now it's a full table scan, every row, every time, and that's for one word. People type best running shoes for flat feet and expect the right heads, ranked instantly. Your database has no idea which row is more relevant, it only knows match or no match. To do search properly, you have to flip the whole problem around, literally. A normal table is a forward index. Each document points to its words. Document 1 contains these terms, document 4 contains those, and so on. An inverted index flips it. Each term points to the documents that contain it. The word checkout maps to a list, doc 1, doc 4, doc 9. The word payment maps to doc 4 and doc 7. Now, a search for checkout isn't a scan, it's a single lookup. You jump straight to the term, grab its list of document IDs, and you're done. That list of IDs is called postings list, and it's the heart of the whole engine. Search checkout payment and you just intersect two postings list, the documents in both. This is the one idea that everything else is built on, term to documents, not documents to terms. But there's a catch. How did checkout become a clean, lookable term in the first place? Raw text is messy. Human reads checkout with a capital C, checkout with everything small, and checked out with hyphen as the same thing. A raw string comparison does not. So before anything gets indexed, it runs through an analyzer. First, character filters clean the raw text, strip HTML, normalize punctuations. Then the tokenizer breaks the stream into tokens, splitting on white space and punctuation. The fast checkout page becomes four tokens, the fast checkout page as separate words. Then token filters transform each one, lowercase everything. So checkout with capital C and checkout with small c collapse together. Drop stop words like the and a that carry almost no meaning. And stem the rest, running, runs, ran, all fold down to run. So the messy title becomes a clean set of terms, fast checkout page. Here's the part that people miss. Your query runs through the exact same analyzer. You search running, it becomes run, and it matches a doc that stored run. That symmetry is the whole trick. Okay, so you have found the matching document, but which one goes first? This is where search stops being a database and starts being a ranking engine. The classic answer is TF-IDF, and its two intuitions multiplied together. Term frequency. The more often your term appears in a document, the more that document is probably about it. Inverse document frequency. The rarer a term is across the whole corpus, the more it matters when it hits. The word the appears everywhere, so it's worth almost nothing. Kubernetes is rare, so a match there is a strong signal. Multiply them, frequent here, rare everything else, and you get a relevance score. Modern Elasticsearch uses BM25, a refinement of that same idea. BM25 adds saturation, that is, the 10th occurrence of a word matters way less than the second. And it normalizes for length, so a short focused document isn't buried under a long one that just repeats the term. That score is why the right result lands at the top instead of somewhere on the page 4. Now scale it. One inverted index on one machine is great until your data doesn't fit on one machine. So Elasticsearch splits an index into shards. Each shard is a complete self-contained inverted index. Under the hood, every shard is actually a Lucene index. Lucene is the library doing the real search work. Spread those shards across nodes, and now your data and your query load is split across the cluster. Each shard also gets replicas, that is, copies living on the other nodes. A replica is two things at once, a backup if a node dies, and an extra copy that can serve reads. Lose a node and a replica gets promoted to primary. The cluster heals itself and stays up. This is how one logical index quietly spans a dozen machines and keeps answering. So what actually happens when a query lands? It hits any node and that node becomes a coordinating node for your request. It can't answer alone, that is, the data is scattered across shards, so it fans the query out to every relevant shard. This is scatter gather. Each shard searches its own slice in parallel and scores its local hits. But here's the efficient part. In the first place, shards send back only IDs and scores and not the documents. But the coordinator merges all of those mini ranked lists and sorts to find the true top 10. Only then does it go back and fetch the full documents for just those 10 winners. So that is query then fetch. Rank cheap on tiny metadata, fetch expensive only for what you'll actually show. One more thing that trips people up is that Elasticsearch is near real time and not instant. When you index a document, it doesn't hit the searchable index immediately. It lands in an in-memory buffer and it's invisible to search for now. On a refresh, by default, every 1 second, that buffer is flushed into a new segment. A segment is an immutable mini index. Once written, it's never edited, only added to or later merged. That immutability is a gift. That is, no locks on read and old segments get merged in the background. It also means an update is really a delete plus reindex and a brand new document is searchable about a second later. That 1 second gap is the price you pay for the speed on the read side. It's almost always worth it. So step back and watch the whole pipeline for a single search. Your text is analyzed into clean terms. Those terms live in an inverted index. That index is sharded and replicated across a cluster of nodes. Your query is analyzed the same way, scattered to every shard and scored with BM25. The coordinator gathers the top IDs, fetches just those documents, and hands you a ranked page. Every one of those steps exists to avoid the one thing your database was doing, that is scanning everything. So that's a whole magic, not more hardware, a structure that already knows where every word lives. So that's how search actually works, from a full table scan all the way to a structure that already knows where every word lives. I'm Aseesh. If this helped it click, a subscribe genuinely helps the channel out. Either way, I'll catch you in the next one. Thank you.